Kubernetes logo. This one. Okay. So whenever you see this Kubernetes, the logo is steering, actually a ship steering. Okay. So Docker is a ship and this one is a ship steering, which is nothing but it can manage, it can drive your ship to your destination. It will help you in your navigation at which direction you want to move and how to drive, and it will manage your engine as well towards your destination, right, in a general way. So here also Kubernetes do the same. So to do that, I can give a technical name to it, that is orchestration. Kubernetes can do orchestration. Where it can do orchestration? It can do orchestration on containerization. It can do containerization level only. It can do orchestration. So who will do containerization? Docker will do the containerization. On top of Docker, it can manage and orchestrate. For that purpose, we'll use Kubernetes. So let's discuss some Kubernetes from the standalone point of view, and then we'll come to the managed Kubernetes. Okay. So in industry, people are calling Kubernetes as K8s. Why we are calling K8s? If you see the spelling of the Kubernetes, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 letters are there. So I can keep K and S in the last. In between, 8 letters are there. The shortcut is K8s. Okay. Shortcut is K8s. That's why right now everyone, everywhere, Kubernetes is named as K8s, again a short form. Okay. Now, who is developed this Kubernetes? It is developed by Google in 2014. In 2014. Okay. In Go language program they have developed, and it is having the version at that time 1.15. 2014 v1 v.14 v1.14, sorry, v1.14, then it is v1.15. So when it is v1.15, Google is donated this product Kubernetes to CNCF cloud. Okay. So cloud native compute native cloud federation, CNCF, it is like WHO. For the health we have a WHO, right? In the same pattern we have CNCF all over the world. All cloud service providers are going to report to this. It's having a organization, it is an authority, it's having authority. CNCF, they are given to CNCF, and here CNCF is having good developers, a very good developers on the Golang, Linux. Basically Kubernetes on the Linux based only, Golang again. So they have very good developers there. They have did few future developments. They added more features into it. They did a good development in the Kubernetes. That's how it came out into market from 2016 to 17. From 2016 2017 it is came into market and everyone started using it. The features are get to know outside, and from 2008 it is into the market fully. From 2009 it is more, actually from 2008 it is more in use, because everyone got to know the advantages of the Kubernetes. So this is the history on the Kubernetes. Again, what are the features it is having? Why should I go for the Kubernetes? Okay, for that let's discuss the architecture first. Okay, and then we can go for the features. Okay. So before that, sir, why would I first go for the architecture? Can I know the advantages? Okay, advantages. It can do load balancing. Okay, it can do load balancing first. What load balance it can do? Containerization load balancing, because we have a containers deploying here, right? That's how we are using some. Someone is okay. Someone is on video, might be. It's given a gallery. Okay, fine. Okay, fine, fine, good. Okay, fine. So now Kubernetes can do load balancing at my containers. We are already doing containerization by using Docker, right? Right? It do load balancing on scheduled containers. Okay, it do load balancing on scheduled containers, and it is having load. It is having scalability. Okay, and it have high availability, and it is having portability. Whenever someone asks, you can just say these are the common points which Kubernetes, by using Kubernetes we can leverage this. Okay, and it is very extensive. Extensive, yeah, and it is declarative actually, means easy to write, easy to define the things. Okay, and it is more efficient. Whenever you say these points, someone will like declarative, efficient, extensive. Yeah, I even know what exactly it do. Portability is important point, high availability is important point, scalability is important point, load balancing is more important point, declarative is important point. These 2 points, okay, but these are the main points you should mention in your answer. Okay, why do I go for a Kubernetes? And it is having one more important thing, self healing. Okay, it try to do self healing. That means whenever it find any trouble at container at pod level, it try to create the new container, try to exit and try to create a new container to get up and ready container. It try to do self healing. Okay, it's completely it is having a damage, then it will recover itself. No, like not like that. A feature, a behalf of a feature that it can do, that it try to recreate the container if whenever it find issue. Okay, so that option is here. Is that option present in the Docker? No, Docker by default not having rebuilding the container when it is found issue in the container, but Kubernetes can do. If you provide configuration, it can rebuild your pod whenever it find the issue on it, but the Docker cannot. Docker is just a runtime. I'll tell you, Docker is just a runtime, container runtime. Okay, let's have a Kubernetes architecture. Hmm, not even load. This is somewhat a high level thing, but you will not understand properly. So what I'll do, I'll create a diagram with our exact workflow. Okay, now this outer one I can call it as cluster. Cluster means group of servers at one place. That is cluster. It's a logical boundary. So these three are my servers. So this is the master server. Okay, and these are the worker nodes. Two worker nodes. Two worker nodes. These two. Node 1, node 2. Let me call it as node 2. Okay, node 2. So in this master, I will be having few services for the Kubernetes. Okay, whenever you're trying to create Kubernetes, it creates first a logical boundary cluster. In it, you can add the servers. So it is automatically going to add the servers in it. On top of the servers only, it will create the cluster. So inside my master server, I'll be having Kube API. Okay, first one, and then controller, control manager nodes. Third one, second one is scheduler. Okay, and fourth one is etcd. Okay, so these are the things will be in my master. And then in the worker nodes, what will be I have kubelet. Okay, I'll be having the same here as well, and I will be having kube proxy. Kube proxy. So these are my worker nodes now. Kube proxy I will be having here, and kubelet I will having in the nodes. Let me enclose with this. Okay, yeah. So on top of this, I will be having a runtime. What is the runtime? Docker is the runtime. Docker is the runtime. Runtime means, so the tool which you are using to create a container. What are the alternatives we have for Docker also? We have LXC in Linux, we have RKT, right? Rocket. So these are the alternatives. You can also create the containerization by using them. That is a runtime. But Kubernetes is specifically giving support on Docker containers only. Okay, it can only manage the container which created by the Docker. If you're trying to do containerization by LXC, containerization runtime, it will not support because there's no features are developed in it. It can only do on the Docker. Now let me duplicate the same. Yeah. On top of this, I will be having the pods. So this is one pod, second pod, third pod. Okay. Otherwise, I'll take only two pods in one node. So there will be no pods in the master server. Everything will be in the worker nodes only. So inside this pod, there will be a container going to run. Okay, that is my Docker container. This one is my Docker container. Okay, so this is pod. This is pod. Inside that there will be a container. This one. Okay, that is my container going to run in every pod. Then what is a pod? Why can't I run directly a container here? Okay, so Kubernetes is enclosing with one more logical running instance is pod, because it need to do lot of things, because by default Docker is not given those features, right? It's just focused on creating the containerization. So I need to apply more features like which I have mentioned before. So to apply them, I need to add one more layer on top of the container, that is pod. I cannot directly apply in the container. Okay, because Docker is not allowing me. That is only for the containerization. So what I can do to make it more portable and more scalable, more scheduled load balancing, scalable and high available, I should create a top of one more service on it, that is a pod. Okay, inside the pod my container will run. Okay, so this master server will communicate with your nodes. It's not like Ansible push based pull based mechanism. It is not related to those words, pull based mechanism, push based mechanism. No, it's just a cluster. Inside the cluster we have a nodes. These nodes are combined and listening to the master. So master will control these nodes. So that's how I can call this as control plane. Okay, and worker nodes are here, right? How they I can call it as node plane. Node plane. So when this cluster is created, right, this cluster also a logical network, and it will have an IP address for it also. Logical network, it will be having an IP address for it. Now let me also do this one. Yeah. Now Kube API, scheduler, controller, etc. So whenever I want to, or I want to communicate with this Kubernetes, I can communicate with the two ways from my laptop. From my laptop, I can be communicated in the two ways. One is terminal, one is GUI. UI. UI is nothing but once you installed, you can have the dashboard of the Kubernetes. But you want to directly create? No. Okay. So whenever I'm trying to communicate with my cluster, I should have the two paths. One is terminal and UI. And here you will be having the component, command line component to communicate with the cluster is kubectl. Okay, so when we are talking with the Docker, we are giving Docker run command, right? So then that server kernel will forward me to that talk with the Docker. Here also, whenever I want to talk with the Kubernetes, I should always talk with the kubectl. Okay, then only Kubernetes can understand that this guy is talking with me. If not, no, it cannot understand. Okay, so this is a complete architecture. Now here Kube API is responsible for everything. API, application program interface. It is going to enable the communication between all your services inside the cluster with your kubectl as well. Okay, with your kubectl as well. So this Kube API will communicate with your kubectl. Whatever you are saying, it will communicate, and it will communicate with the scheduler. It will communicate with the controller. It will communicate with the etcd. It will communicate with the kubelet. It will communicate with the kubeproxy. It will communicate with the your pod. Okay, so in all ways Kube API is responsible to communicate. Okay, so whatever I'm telling something, hey, create a pod, then Kube API will take that, tell to schedulers that, hey, this guy wants to schedule a pod. Okay, then that went to the controller. Controller will say, oh, so scheduler wants to schedule something. Then whatever the controller will maintain this nodes. Let's come from the start. Kube API is the interface that communicate with every service inside the cluster with respected of the kubectl instruction. Okay, scheduler will manage to schedule pods inside the available nodes. Controller is responsible to control the nodes and pods to be up and ready for your scaling purpose, deployment purpose. Controller will manage your scaling and scheduling and deploying actions. etcd is nothing but your local database of your cluster. It will have a key value pair data inside in it. It will act like a database, local database for your cluster. It holds the information of pod, in which node it is got scheduled, what is the name of the pod, what is the other logs of the pod, everything. etcd will maintain that information inside the cluster. Okay, and then what is a kubelet? Kubelet is responsible to, it is completely going to run and responsible on the worker node 1 only. Okay, the kubelet there in the worker node 1, right here in this. So it is only responsible here, that it is make sure or ensure that the pod should up and run in the node. It is responsible to maintain the node of runtime, proxy, and what are the things are going inside the node. Okay, kubelet is responsible. And kuproxy, kuproxy means it is helping me whenever I'm exposing my pod, whenever I'm exposing the pod to outside to get application access. Kuproxy will helping me for load balancing. So proxy is nothing but it will hide my original network, the original IP address of my pod, and it will show something duplicate outside. It can be a node port, it can be a load balancer, it can be a cluster IP, it can be a headless, it can be an external name. Okay. So Docker is the runtime here. What is a runtime? Runtime means the action which creates the final container. If you observe in our Docker multi-stage file as well, we are calling two images. The first image as a builder. The last image is going to be a last container which is we able to see, right? That is runtime container, the final container. So who is creating that? Who is helping me to create that container? Docker. So Docker is my runtime. Okay. And you are creating the container, right? So when you are creating Kubernetes is enclosing inside a pod. So you have to create a pod. Okay. Pod is nothing but running virtual instance of your container. Running virtual instance of your container. That is pod. So whenever I want to expose this to outside, so inside my container my application is running, so I want to expose outside. So what are all the service I can use? So Kubernetes is having these services, while kuproxy will involve and helping in it those node port, cluster IP, load balancer, external name, headless, external name, headless, and ingress controller. These many services are helping me to get done my pod expose outside. Okay, the complete Kubernetes architecture. Whenever in your interview, if someone asks you, hey, can you just please explain the Kubernetes architecture, make sure you have to explain this. Whatever I today explain. Okay, this is high level explanation. Many things are there outside. Lot of confusion in it. Explain the Kubernetes architecture. Okay. Node port, cluster IP, load balancer, external name, and headless. Okay. Now, what I missed here still UI kubelet terminal, control plane, node plane, many things. Pod, other services as well, like secrets and config maps and other. We'll go step by step. This controller. Okay. Previously, we should install the master in one server and worker node separately, and then we need to join this worker node to the master like we are doing for Ansible. Okay, that is completely on the standalone Kubernetes. We are downloading SonarQube, right? That is standalone tool. Like that, Kubernetes is standalone tool. You can do that. But cloud service providers are doing a business with this. Cloud service providers are doing a business with this. So what they are doing? Hey, why you are installing the Kube master in one server? Basically, I'll tell you what is the business strategy here. For example, you want to download this. Okay, give me a minute. Yeah, for example, I want to set up this Kubernetes. Okay, what I'll do, I'll go to AWS cloud, I'll create one T2 medium, T2 medium 3 servers, I'll install Kubernetes, the master or worker nodes, I'll join in it, right? So I'm only paying for server. I'm only paying for server, and I'm struggling to do the Kubernetes configurations. I need to fire the manual commands, I need to join. If whenever this node is down and I need to go for another node, that another node should be again joined to the Kubernetes master. Okay, manual work is needed here. So by catching this point, okay, if I am doing the same, I'm only paying to the server, I'm not paying to the Kubernetes. Kubernetes is free. So by catching this point, AWS came, GCP already having those things, AWS came with an idea that so I will automate the master. So you no need to install this master configurations in a server. You can go to the node plane because the applications will run here. Applications will not run in the master. Application will run in the node plane. So I can give you service like options master in the AWS console. Okay, I will manage control plane completely. The only responsibility, you can go for node plane, you can create and schedule your things, configure your configurations. So this business is named as EKS, Elastic Kubernetes Service. When it is EKS, it's managed EKS, managed Kubernetes, right? Master is managed by AWS, right now, managed Kubernetes. If it is in the Azure, then Azure came AKS. Already GCP is having the same thing, but they are advanced it, GKE, Google Kubernetes Engine. This is how managed Kubernetes now. We no need to install master things in the server. So everything is available at the cloud service point, services point of view, and you can do the configurations. Then every cloud came with the same business. Again, AWS came with one more idea. Hey, in EKS, you are typing the commands, you are doing configurations once your Docker image is available, you are writing manifest files, you are giving configurations, you are doing declarative and imperative manner. Always, you are maintaining more. Why you are going struggling that much? I have created a one more service called ECS service, Elastic Container Service. Elastic Container Service. Now in this, You just need to available the Docker image. That's it. Then after, create a task in the GUI manner. No need to log into the terminal. Create a task and run a service. That's it. No need to fire any kubectl command and nothing. You can do deployments more advanced manner. By catching this point, they are doing business on us. Okay. So this is how the Kubernetes is now. Whenever you're seeing three nodes covered inside the one logical boundary, name it as a cluster, then it is called kubeadm. Kubeadm is multiple nodes. Then if I configure this Kubernetes in single node, I can call it as mini kube. Okay, mini kube. Okay, so when multi nodes, it is a kubeadm. When single node, it is mini kube. Okay, so this is the things. So why I need to go for kubeadm? Why I need to go for mini kube? Mini kube is for our testing, learning purpose, POC purpose. We do. Okay, kubeadm is the production ready environment. Kubeadm. Okay, so this is complete architecture. Let me open a document, then you will get good understanding as a document. Yeah, what is Kubernetes? Advantages Kubernetes, you can read out all the things whatever I said: deployment, scaling, containers, container load balancing, the information which I give, Golang, cloud native computing foundation in 2014. Okay, 14 version and then 15. Okay, and it is having these features: automated scheduling, self-healing capabilities, automated rollouts and rollbacks, horizontal scaling, and load balancing. I'll tell you this. If you come to service discovery and load balancing, storage orchestration, this is the architecture, but this diagram is wrong in this pod point. So inside the pod there are container 1, container 2, container 3 is there, right? So in ideally inside a pod there will be only one container. There will be only one container. That's it. Okay. In some cases inside the pod there will be two containers, but there will be no three containers. It's wrong, completely wrong, not ideal manner. No one is not using. Okay, so one pod is ideally have one container. Whenever anyone asks in interview, say one pod is one container. That's it. And we'll do lab also. You'll get to know. We cannot do three more containers in a pod. So one pod is one container. That's it. So if you go and talk about the components, kubectl is a command line configuration to interact with the master, and kubelet has the config file and kubeconfig, which is going to store your information and talk with the API server. Master node components: kube API server, server which interacts with the front end of the Kubernetes control plane. Okay, scheduler watches the pods and assign the pods to a specific host. Host is means nothing but servers. Controller control and manage the controllers in the background which runs the different tasks of Kubernetes clusters at cluster level, like replication, keeping track of worker nodes, and handling the node failures. Okay, so we have different type of controllers. We'll be having the classes on this. etcd is nothing but simple distributive key value store which Kubernetes used for the database. Store the cluster data like scheduling the information, pods and state information, etc. in etcd. Worker nodes. Kubelet is a primary node agent, runs on each node, reads the container manifesto, which ensures that containers are running up and healthy. Up and healthy. Okay. It makes the container running pod. Kubelet doesn't manage the containers which were not created by the Kubernetes. Which were not created by the Kubernetes. I'll tell you the example of this. Why the point specifically mentioned. For example, I created one node and I have added to this Kubernetes, or this worker node is already created by the Kubernetes and I logged in manually. I created a container by Docker with the Docker commands. Does my Kubernetes going to manage that? No. If Kubernetes creates, the container can be enclosed in the pod, right? So however Kubernetes is managing the containers, so if I create the container by Docker, it will manage? No. That's why this point specifically. Okay, it can only manage the thing which is created by Kubernetes. Okay. Kuproxy is enable service abstraction by maintaining network rules and host performance configuration, which helps me in load balancer. Okay, exposed via Kuproxy. It will not manage the, if you are creating the container manually by the Docker, then it will not manage. Kubernetes itself is already holding the runtime of Docker. Okay, by using that, if Kubernetes creates, then only it will manage. Okay. Yeah. See, container runtime. Each node must have the container runtime such as Docker, RKT or another container runtime process instruction from the master server to the containers. No. If you try to create a rocket container, then it will only create the container. It will only create the container. Then how come you enclose in a pod? To enclose in a pod, what you need? Again, Kubernetes you need it. But whenever you are downloading the Kubernetes distribution, it's coming with the Docker. It's not coming with the LXC. It's not coming with the Docker. Okay, I can also write it down here, LXC. It's not coming with the LXC. It's not coming with the Docker. Okay. So when it is coming with the LXC and RKT, the feature is available in the Kubernetes, then it can work. But right now, whatever the Kubernetes you are going to download, it comes to the Docker. Okay. So there will be one more thing, Podman, the alternative of the Kubernetes. Podman, Docker alternative, right? Podman is also there. So if you search Podman, no difference. this you can read out. Container, actually a podman is a daemonless. First thing, Docker, Kubernetes, podman. Docker is a container runtime. Again, see, is a container runtime engines for building. Kubernetes for orchestration. Podman container runtime and management tool that can do a containerization. Running and distributing the containers, containerized application across the cluster machines. Provide Docker compatible CLI container runtime in the podman. Okay. Coming to orchestration, Docker Swarm we have. Kubernetes Podman does not have the inbuilt feature of the orchestration, and Docker Swarm also not having a much features in it which can be scalable at high peak level, high availability. So which one is the option? Kubernetes. That's why that is boom in the market. Everything is on the Kubernetes now. Cluster level, security level, user interface level, you can have the thing. Someone is writing this blog, it's good. So basically what I know at high level, okay, I'll try to write it down. So high level things between the Kubernetes and Podman and Docker. Okay, so Docker again the containerization, but uh, Kubernetes maintains the pod and its life cycle. The first point I would say, it maintains life cycle. Okay, and it do orchestration. You guys, orchestration means it will manage the containers and pods inside a cluster. It will drive the show. Okay, so the process of driving the show is orchestration, managing, maintaining everything. That is orchestration. If you type orchestration meaning, normally in general uh, words, the arrangement of scoring music, not music. Orchestration. Automation and orchestration are distinct but related concepts. The planning of coordinating of element in a situation to produce desired effect, especially what is this? Surreptitiously. I can't able to pronounce it. So the orchestration of the campaigning needed tightening is described with the setting of tax policy as it's something to, it's referring to something another thing. But basically orchestration is which is driving and managing the things. Let me search on the Chrome. Edge will give you a lot of other things. Edge will print unwanted content sometimes. Allows you to build application service that span multiple containers, schedule containers across the cluster, scale those containers, and manage and health over time. Manage the things, managing every component service inside the cluster, that is orchestration. Okay, orchestration. And again, we have one more alternative for this Kubernetes is OpenShift. OpenShift OpenShift is from Red Hat Cloud. Okay, it's from Red Hat. It is also providing the same, but it has its own container thing, runtime thing. Okay, it can do orchestration from Ansible also, Ansible Tower. Okay, so the basic core differences between these two. Okay, so in the Kubernetes is an open source one. We no need to pay any single rupee. But coming to OpenShift, we need to pay the money, which is developed by Red Hat. We need to pay the money to it. We need to take a license. Okay. Kubernetes is framework automated deployment kind of thing. OpenShift is having additional features that will give you more in the productivity, security, and operability. That means you can configure the things according to your desired project configuration. You can request to the OpenShift also if you really need that kind of support. So the productivity is more on the OpenShift comparing with the Kubernetes. Uh, this is the one point I would like to say from the real-time experience. And features wise, I can say Kubernetes provides the same kind of orchestration of maintaining ecosystem. OpenShift also do the same thing. There's no difference in features. Uh, but uh, uh, but yeah, Kubernetes is not having the container registry. I got. Let me. Yes, 21. Yeah, this one. Actually, source to image. That write image and applications source code input to produce the new image. But we are doing it Kubernetes. We are doing program and developing through the Docker. But here it is providing me S21 things which you can write down and for the image creation. So that image you can directly utilize to run it as a container in the OpenShift. Okay, build process source S21 script and builder image workflow CI/CD process. This one part of CI/CD, not sorry, part of CI/CD, not CI/CD. So build and publish part, only this two steps. Build and publish part. This is involving in OpenShift. Okay, and security manner. My Kubernetes will give RBAC roles. RBAC. Okay, role-based access control on the pod level, but my OpenShift gives SCC, security constructs constraints on the OpenShift. These things which do pod must be run with the accepted into the system, like it's provide uh, a kind of a set of privileges which match security context constraints which you gained through the privileges. Okay, this one and coming to the experience of DevOps engineers on the both platforms. Okay, so basically Kubernetes is a primary focus, I would say, because it's very easy to maintain. Write down, do. When people are habituated to the Kubernetes, is sometimes standalone and clouds are already using it. Easy to understand, easy to coordinate, easy to deploy the things. Whereas coming to OpenShift, we need to use IDE integrations like VS Code, PyCharms for that, and developer experiences are like a kind of little complex comparing with the Kubernetes and OpenShift. Okay, coming to commercial support, like support, you will get a support from the OpenShift if you are stuck at some point. There's a team can help you. But Kubernetes, who is the owner? No support. So you're taking the managed Kubernetes on the AWS cloud, then AWS can support you at some extent only. Okay, that is a problem. I hope I cleared complete theory part on the Kubernetes. So we'll go some more deeper if you clear today's class. Got some understanding, need to read again. Okay, go through this document. I'll give you. There is some junk information also present in this document. I was I removed lot of things in it, and means I made like uh, section by section, but still need to remove a lot of junk things from it. I need to alter these definitions. Okay, so like how we do have this play with Docker, we do have a play with OpenShift as well. Sorry, Kubernetes. Sigma, it's clear, but we do lab and make it more clarity. Okay, you guys kindly attach the diagram. Yes, I will attach the diagram. Add instance. So here, right now, this is my mini cube, single server. Okay, the single server. It is giving me an option to boot it. Initialize the cluster master node. Okay, so what you can do, select this, control insert, and shift insert, paste, execute. I don't know how accurately it will create. Let's see. This is going to enable. Oh, it's giving failed to pass with kernel config, unable to load kernel module configs. The command which it is giving only we are running. It's done. So if I want to add node, okay, see, it is giving me what? Kubeadm join this command. Okay, I need to attach this. So let me do copy, control insert. I'll put it in somewhere. Okay, but let me enable this by going above, initializing the cluster network. Okay, I'll go and control insert, shift insert. I'll enter this. So it is created. If I run kubectl get nodes, I want to see the node information. You can see node 1 is available, that is control plane master server having version of v1.27.2. okay, the latest version is v1.29. v1.29 is the latest version on the managed Kubernetes. Since it is standalone, it is v1.27. Now I want to add a node, so I'm going to take node 2. Okay, node 2 I would like to take. Kubernetes minute I don't want. I want to add this one. Okay, shift insert. Warning, failure to contain. This node has joined the clusters. You can see. Okay, if I come here, if I do kubectl get nodes, I can see a one node which is none, no role is there. Okay, node 1 is a master, node 2 is worker node, that's why it's not showing control plane. Let me go with third node, shift insert. Okay, no, from the nodes I am running this. To join I need to run. No, these commands I took here. Here these are the commands 1 2 3. So when I given this first command, here it is giving me, see, then you should now deploy the pod network on the cluster. Alternative, you have user run kubeadm, then you can join any number of worker nodes by running following on each route. So this command I copied, this command I'm running in the node 2 and node 3. Okay, from master server only it took. Now I can see get nodes. Node 2 and node 3 are the worker nodes. Okay, just a sample thing itself is giving me a manifest file to run nginx. Okay, kubectl apply -f, this is the GitHub repository where nginx app.yml is written. Okay, shift insert, shift control insert and shift insert. When I going to run, it creates the 3 nginx pods. Deployment.apps, my nginx is created. I want to see the pods. Kubectl get pods. 3 pods are there, they are running. Okay, 3 pods are there, they are running. So how can I see? We need to expose that as well, I think. But we need to analyze this, what configuration is given here first of all. Okay, let's see that kubectl describe or kubectl get svc service I want to see. So I want to expose means I have a services, right? Load balancer, node port, get svc. I have load balancer that is pending actually. It's not created properly. Pending. svc is pending. I think any issue, some issue might be here. Uh, okay, what I'll do from the master, you just don't worry about these things. Uh, kubectl expose, I would say load balancer pending none external IP. Okay, expose, I would like to create a pod. The pod name is Rajini. Okay, hyphen type, I'll take a node port. Okay, hyphen port, port number is, let's say, 8080 or 8080 or 2024. Okay, port forwarding. Hyphen target. Okay, port hyphen target port. Uh, then I should target port. Here, what I need to do? Target port I need to give it as 2024. I think. Here it is a default port number. 80 is a default port number. Then I can give 2024 as a target port number, and then the container I want to take it as a Nginx image. So it is directly going to pull from the Docker hub since the Docker is a runtime. But I didn't created a pod. Again, this one type is equal to node port capital N. Okay, Rajini. So no, not found. So kubectl run Rajini is the pod name, hyphen image is equal to nginx. Pod is created, kubectl get pods. I have Rajni pod, container is creating, it's up and ready. Now I'll expose this. Yes, it is exposed. If I see kubectl get svc service, don't worry about this. We'll again discuss these things. Node port is 312332, but it has to give me an option to expose here. Okay, this is the URL 31232 31232. It's not came. It's a complete a private network. It has to show me like a Docker play with Docker thing. Uh, what can I do here? Okay, this port explosion. Only play with KTS thing. What is this kind of answer? Then why you need to write this answer? Node port never exposed URL. Node port is what? This is cool. People are like really while creating service and node port and play with Kubernetes. He said he's explaining about node port. Especially play with Kubernetes website. That's SVC is done. Having 10 106 87 1 10 is a private, right? Private IP address, no external IP. Settings option. Okay, then what I can do? I can do something like curl. I can check with the curl. This IP address, control insert, shift insert, colon 31232. Then it has to return me Nginx HTML page. No. Node port. Oh, node port. Node port means I have to take this IP address, man. Node IP address 192.168.0.17 is node 2. Failure to connect. Connection refused. Private network. That is the problem. No. Okay. But you can practice the things here. I think the exposing is a problem here in this one. So we'll set up a mini cube in one Ubuntu server and then we'll do practice from the next classes. We'll jump into the Kubernetes step by step. Okay, everyone is clear as of now? Scrolling is works here normally, mouse scrolling. Yeah, cool then. Okay, we'll make